You was in the last class?
Last class, sir, I don't think so.
Okay, no problem. So we started, what can I say? Gravitational force. So I'll give you a brief what is gravitational force. Mm, 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 mm. Okay. So let me show you. Tell you over here. Suppose we have two objects, right? We have two objects like this is our Earth and here it is Moon. Clear?
Sir.
Suppose mass of Earth is capital M and mass of Moon is a small m. Clear? So, and distance between these two objects is what? Suppose d. Clear?
Yes, sir.
Hi Jabbar, how are you? So Jabbar, you have to, and if possible, kindly open the videos, okay?
Yes, ma'am. Yes, sir.
You still have background noise, okay? You didn't fix it. So the force between Earth and Moon will be equal to or proportional to the product of these two masses, mass of Earth and mass of Moon. The force between Earth and Moon will be proportional to the product of its masses and inversely proportional to the distance square or separation square. What is that? D square. Clear? Where alpha is proportionality constant. This is proportionality pro for TIONALITY proportionality constant, right? It is advised to keep the video on. So at least I will be able to understand how you are dealing with situations. So if we will remove this proportionality constant, the force will be equal to, will bring a constant over here, G, and this will be M, mass of Earth and mass of Moon, divided by the separation square, that is D square. So this is formula for universal law of gravitation. Universal law of gravitation. Clear? The constant G is called where G is what? Constant, and its value is 6.67 into 10 raised to the power minus 11 Newton meter square by kilogram square, right? Clear?
Sir, clear.
Okay, so this is the basic fundamental rule. Okay, so now you have a question. The mass of Earth is this, and that of Moon is this. If the distance between Earth and Moon is 3.84 into, here is into 10 raised to the power 5, calculate the force exerted by the Earth on the Moon. Take G key value 6.67 into 10 raised to the power minus 11 Newton meter square per kilogram square. Can you do it? Will you solve it?
I will try, sir.
Okay, try. It's the simple based on that formula. So I have to show you formula. I'll just write it. I am writing over here that F will be equal to G mass of Earth and mass of Moon by the distance square. Clear? So can you do it? Put the Rumaiza, we have this question to solve, okay?
Okay, sir.
What happened?
Sir, I can't figure it out.
Okay, no problem, no problem, no problem. Rumaiza,
Sir, what is the value of G again?
value of G is given over here, dear. This is the value of G.
Sir, you have to write it same way.
Yeah, we have to
So,
write it as 6.67 to 10 raised to the power minus 11. If you want to write these numbers in m square kg inverse, it's okay. Otherwise, we know the unit of force is Newton. So finally, we will place it in Newton. That will be kilogram meter per second square. So again, put the value of capital M, that is mass of Earth, 6 into 10 raised to the power 24, 6 into 10 to the power 24. Then
So
7.4
I got the
into,
answer as 2.02 into 10 raised to 20 Newton.
okay. So Rumaiza got the answer right.
Yes, sir.
And this will be, so Rumaiza, you do the another question, calculate the value of G. Today I got the mind that I'll take some surprise test. Okay. So calculate the value of G. Understand the problem? That will is equal to 9.8 meter per second square. How you will calculate? It depends on you. Now put 7.4 here, 7.4 into 10 raised to the power. Oh, 7.4 into 10 raised to the power 22. Mm, 10 raised to the power 22. And what is the difference distance between these two? Is 3.84 into 10 to the power 5. Right? A square of it. Clear? Is clear to everyone?
Yes, sir.
Okay, so
Yes, sir.
can you do this calculation? If I'll open the calculator, I have to minimize the screen. So do this calculation. How you will do this calculation? So this is 10 to the power 5 into 10 to the power 5. So first I will write it 6.67 into 6 into 7.4 into 10 raised to the power minus 11 and 24, 22 is 6, 4, 46 minus 11. So minus 11 will be 5, 3, 35, right? So it will be 10 to the power 35. Clear? Now, this is 3.848, 3.84 into 10 to the power 5. Because it is a square, so I'm just writing is 10 to the power 5. Clear? Any doubt?
Clear.
Okay. So see, this is now next step. Let me change the pencil color. Okay. So this this point will be cancelled. Clear how? If you will translate it, it will be 667 divided by 100. Here 384 divided by 100. So this will get cancelled. This is 10 to the power 5. 10 to the 5 is 10 to the power 10. So if we will take this upside, it will be 10 to the power minus 10. Clear? So this will be gone. So now again, if I'm not doing much, I'm again writing it 667 into 6 into 7.4 into 10 raised to the power 25. Here it is 384 into this is 3.84. Clear? 10 to the power 5, 10 to the power 5 is gone. So if we want to solve it, I will put just 1 0 over here and we'll remove this decimal over this decimal. So you have to do nothing, just calculate this value. Okay. And whatever the number you are getting, put that times Newton. Clear? Do it right now. If you have calculator or manually, whatever you can, just do it. Maza, did you get the value of a small g?
No, sir, I'm fine.
Okay. We already calculated it in the last class, right? So once you are done with this question, then solve the next question. Calculate the value of g. If you are having any issue, ask me, I'll give you hint. So if I'll do this sum, let me use the calculator. So what final we will be doing? 2.0 dash. So for that, I have to multiply it by 10 and divide it by 10. So it will be 10 raised to the power 26 Newton. Clear?
Yes, sir.
So you have to do the practice. What about the second question? Calculate the value of G. So those who are attending the first class, for them, I'm just giving a hints. See, suppose this is apple. This is apple and this is earth. Earth. So earth is attracting it toward a force M into G, which is equal to G M of earth, or this M is mass of apple, about the distance between these two. If distance between these two is d, though it will be d squared. So this m or m will get cancelled. We will be leaving with g is equal to capital G m and distance between these two whole square. So we are aware of value of g. We are aware of value of mass of earth and the distance between these two. So distance between these two, if you will substitute this value, the radius of earth. Radius of earth, what is the value of radius of earth? Anyone know? Anyone is aware of the radius of earth? So radius of earth is 6.37 into 10 to the power 6. 6.37 into 10 to the power 6. So if you will replace d equal to 6, d is equal to 6. 37 into 10 raised to the power, what did I say? 10 raised to the power 6. 10 raised to the power 6. 6 kilogram. Okay. So if you will put all these value in this equation, you will find the G. The question arises why we are taking the radius of Earth as the radius at these distance, because the tree of apple is not very that D is not very greater than radius of Earth. Got the point? So D is in respect of Earth is very small. So in another word, we can write this equation as, let me erase some part. Let me erase some part so it will be clear, and we will get some space as well. So this will translate into G is equal to G mass of Earth divided by R square, where R square is radius of Earth. Okay, substitute the value of all these quantities. I already said that R is radius of Earth, which is equal to 6.37 into 10 to the power 6. Leave the dimensionality, but it is kilometer. And we know the GQ value is what? 6.67. G is 67. G is equal to 6.7 into 10 to the power minus 11. And mass of Earth is already given over here. That is 6 into 10 to the power 24. M is 6 into 10 to the power 24. Without dimensionality. Now put all these and tell me what you are getting the numerical value. Just tell me the numerical value. Rameza, did you get the answer? Any of you got the answer?
No, sir, still doing 1 minute.
Okay, do.
So I got G equals 9.8 into the second.
You got completely 9.8.
No, sir, like
You approximate it, na?
yes, sir. Yes, sir.
6.7 into 10 raised to the power minus 11 into, this is 6 into 10 to the power 24
Divide
into 6.37 into, yeah. Are you saying something?
no, sir.
So do this calculation. Do this calculation honestly. Okay. So if I'll do, where is my calculator? Did you get? Rumeza got 9.8 approx. Let me check. 6.7 into, so first I'll do some manual calculation. So this is 6.7 into 6 into 10 raised to the power 24 minus 11 divided by divided by R is 6.37 into 10 to the power 6. So all values are true or correct? Do you think all values are true? 6 4 kg. Here was some. So if we'll do it, this is, I'll write in one more line, okay? Instead of writing it, we can say 6.7 into 6 into 10 raised to the power. How much it will be? 24 minus 11, 3, 1, 13, right? So it will be 13. And this is, this 6.37, we will write 6.4 into 6.4 into 6 to the power 10 into 10. Now 6 into 6, it is 12. So I'll do like this. This decimal, so this decimal, and rest is again 6, 7 into this 60 into 10 into 6, 4 into 6, 4. So how much we are getting? Nowadays, I'm getting a lot of calculations. So 6, 7, you do simultaneously, okay? Don't trust on my calculation. Sometime I may be the wrong. So backup plan. Of course, it comes 9.814. 9.814. So take it like 9.8. And this is G, so its value will be meter per second square. Everyone got approximately this result?
Sir,
Who didn't get? Everyone, Rumeza, other than Rumeza,
Yes,
Avani, yeah.
sir, I got the approximate value.
Okay, Jabbar, you got the result? Jabbar is gone. Riyaz, you got the result now? Okay, so now I am asking you, take the screenshot or write it down. I am going to ask you a different question. That's the last time we stop there. The concept of weight. We already, can I remove it? I'm removing it. If anyone have any issue, let me know. What do we mean by weight? What do we mean by weight? What do we mean by weight? Weight is equal to mass time acceleration. So if my mass is 60 kg, okay, so weight will be weight will be 60 into 9.8. So approximate will be 70 and weight, the dimension of it is Newton. Clear?
Sir, clear.
Okay. So now I'm asking, now I'm asking, what? It is moon. This is moon. And this is earth. The mass of an object on earth will be what? Mg, this will be equal to G M over the radius of this is R. So it will be R squared. Similarly, the mass of the same object on the moon will be mass of object into gravitation. Gravitation at the surface of moon. Okay. So this is the gravitational constant for the moon. That is same. This is the constant, same. 6.67 at the earth and as well as on moon or any another planet. So capital M is the mass of moon and small is the mass of object that we are measuring. If the radius is R, so it will be R squared. Clear? So
Yes,
this
sir.
relation is always true. If we are measuring the weight of an object on earth, so we will be using this formula. If we are taking the same object like Chandrayaan 3, there might be some object. So if we are taking that Chandrayaan 3 over moon, so if we want to measure the mass of Chandrayaan, we will be using this relation. Okay. So my question is now, can we measure these both? Can we measure this? We all have the known relation. I will put the relation over here. See, this is the relation. The last day we stop here. Today it is my mission to accomplish it. Is this table visible? Visible hai? Is this visible? So now my question, I'm framing the question to you guys. I'm framing the question. The question is, can you calculate the ratio of weight at moon divided by weight at earth? Can you calculate this? If we want to calculate this, what we have to do? We have to use the same relation. Weight at the moon is what? That is this one. That is this one, M times G. So I will write it over here like G and capital M with subscript M stand for moon, right? And then mass of object over there. Again, if we wanna write the mass of that object on Earth, so this gravitational constant will remain same, and we will write M of Earth, E and M. And what we miss? We missed here R of E square and divided by R of Earth. Sorry. This is R of moon and this is R of Earth square. Clear?
Yes, sir.
So what we will be doing, let me change the pen color. So see, this G and this G is constant, that value remains same. Okay. And this M and this M, mass is not changing. Mass of an object either on Earth or on the moon, it is not changing. So these quantity will get cancelled and we will be getting relation mass of moon divided by radius of moon square. Here, this will be mass of Earth, and this radius of Earth will go up straight, and this will become R of P square. Clear? Now what we have to do, just substitute the value of all these quantities. This is 6 point mass of, what is mass of moon? Mass of moon is 3.7 point, sorry. My fault. Rumeza, maybe last day we were doing the same mistake. But today I calculated it earlier. So mass of moon is 7.36, and mass of Earth is, sorry, radius of Earth is 6.37. 6.37 into 10 raised to the power 6 whole square, right? Now, radius of moon is 1.74. 1.74, and whose square into mass of Earth. Mass of Earth is 5.98. 5.98 into 10 raised to the power 2 whole square. Clear?
Yes, sir.
Yeah.
Clear to everyone? What? How you are looking this? Mass of, see how I made a mistake again. This is mass of Earth, and mass of Earth is 5.9 into 10 to the power 24. You guys are not attending. So, I'm removing this. So the mass of moon is 7.36. Oh, where I am. Mass of moon is 7.36 10 raised to the power 22. Radius of Earth is 6.37 10 raised to the power 6 whole square. Radius of moon is now 1.74 whole square into the mass of Earth is 5.98. Clear? Got the idea? So, can I do this calculation? Or you will do it? So, I'm taking it under pressure, okay, or thrust. I don't leave much space. That's one of the problem. So see, I will write 7.36 into 10 to the power 22 as it, and I will write it twice. 6.37 into 10 to the power 6. Or can I tell you one thing? We can cancel this 10. Okay, 10 to the power 6. One. Oh, no. No, that's not the right idea. Right. Let me do some shortcut, otherwise the calculation will be too much. See, 10 to the power 6 and 10 to the power 6, whole square, so it will be equal. So I'm just cancelling out 10 to the power 6. So we are left with 7.36. Why to carry the numbers? 22. So I will write 6.37 twice, 6.37, and will divide it by 1.74 into 1.74. Now this is 5.98 into 10 raised to the power 24. What is the value of? It is 24, right? So see, this decimal and this decimal will get cancelled. This decimal will with this decimal, and this decimal with this decimal. And you will solve it, you will get it 0.16, and this is very much equal to 1/6. So that is the weight at moon and weight at earth equal to 1/6. Clear? Do this calculation at home. I think you will get the result. Clear? Rumaiza? Avani?
Yes, sir, clear.
Clear? So if it is clear, I thought I will ask one question. Actually, this question is being asked last time, but again, according to the environment, we have to ask this question. Under the pressure banner, pressure, it was expected that is this visible? This question is visible. This question is visible.
Yes, sir.
So solve it quickly. An object weight 10 Newton when measured on the surface of Earth. What would be its weight when measured on the surface of Moon? Solve this question. Rumaza, did you solve the last time assignment? Did you solve the last day assignment? We provided assignment to you. Did you solve it?